to this latest edition of GeoTalks Express, What's New in Global Mapper version 24.1. Thanks for taking the time this afternoon, or whatever time of day it is where you are, to talk through some of the newer features in our latest release of Global Mapper. As those of you who are familiar with Global Mapper over the years know, this for us is our middle of the year release. Sometimes we refer to it as a minor release or a dot release, where we add smaller updates and features to the application. And this time I think that this is a really exciting release for a dot release. We have a lot of really cool things that we're going to talk about with you today. My name is Jeff Hassel. I am a product manager here at Blue Marble, and today I'm joined by my friend and colleague Amanda Lind, who is our technical content writer. How are you today, Amanda?
Hello, Jeff. Hello, everyone. I'm doing well. I'm enjoying this fresh snow that really does not make it feel like March outside. How is it spring yet?
I'm happy I'm very far away from that snow, and it's much warmer here, so enjoy it for the both of us.
Jealous.
So Amanda and I today are gonna walk through a whole bunch of new stuff in the application. Before we get into that, Amanda, can you just confirm that I did in fact make my slideshow live?
Yes, I was just about to interrupt you. We can now see it.
Alrighty. So today, unfortunately, we're in listen-only mode. So you will hear Amanda and I speak. If you need to communicate with us, please use the questions panel on this GoToWebinar sidebar. We always will do our best to answer those live and try to interrupt each other as we're going to get some questions answered. If not, though, don't worry. I actually was confirming this with Amanda earlier. We will follow up on all these questions, and they usually get posted to our website as well. So if you ask a question that we cannot get to live, keep an eye out for a follow-up post in email, and you'll get all of the information you need there. And then for those of you who have to maybe run early today or want to share this with colleagues, of course this will be recorded as well, and that give us a week or so to clean it up and post that. But you'll have access to a recording of all that we discussed today too. Before we go ahead and jump into things, just a very quick little sneak peek and update into what's going on in the Blue Marble world, in case you are looking out for other events and things that we may be putting on. So as you know, we're at a GeoTalks Express session right now. We generally have those about once a month, and we have the next, 3 or 4 months already planned out. Where we'll be looking at a whole different variety of our different applications, different topics. Our next one later this month, we'll actually look at Geographic Calculator. So for those of you who do any geodetic and transformation type work, tune in for that talk. That'll cover the top 5 jobs in the application. So give you a bit of a hands-on on how we work with those jobs. I think Amanda and myself will be back for another Global Mapper Pro related talk in a couple months. There'll be some on our mobile app as well. So keep an eye out for all of that exciting GeoTalks Express information. You are probably some way or another familiar with the training that we offer. We do that both in person and online, a variety of public sessions, private sessions, custom sessions. We actually have one going on right now, I think as a public session. So there are some people taking one of our courses right now that our colleague David is running. So if you're someone who has any interest in training, and that could be Global Mapper and LiDAR, it could be geodesy and geodetics, so maybe you are a heavy geographic calculator user or would like to be a heavy geographic calculator user, we have a public geodesy training coming up in a few months as well. So if you're interested in any of that and more, please feel free to visit our website. Our training page will have details on training, If you're interested in any of our written content, I mentioned Amanda is our technical content writer. We have a great, blog posting page where we have articles and case studies from users and things like that. So take a look there. It's a great resource for everybody as well. Amanda, did I miss anything on our upcoming radar for the next few months here?
No, I think our next in-person training is going to be in Orlando, as you said. And other than that, I think we're good to go.
Yeah. Okay, so let's talk a little bit about where Amanda and I are going to take you today. We'll start off going through some of the newer big features in Global Mapper 24.1. We'll start in the standard version of the app, but we'll look at some pro specific features as well. Some of that will cover what I think is one of our flashiest visually new tools, relative elevation model creation. We'll look at inset maps and resampling improvements. And then of course, a whole bunch of little things that, come to our mind and maybe don't need a whole dedicated explanation, but a quick little look at some new, even smaller functionality too, because there's always a ton going on in Global Mapper. And so we try to hit as much of that as possible. We'll talk about a whole bunch of new things in the pro version of Global Mapper. That could be convolution filters, and we'll talk about some customizations to those. Python and the script builder is something I've been excited about. Technically still a beta tool, but a really cool tool to work with that I'll take a look at today. We've expanded some of our automated classification, so you'll be able to see how we have expanded the segmentation-based methods to cover pole extraction. We'll talk about what I often call the MDM tool, or mobile data management. And so we'll talk about updates to that include a new viewer now and different ways to merge our data. We'll take a quick look at some point cloud related workflows, both photogrammetrically with a new wizard in the pixels to points tool, and then looking at the point cloud compare tools. We have, that tool has existed for a while, but we have completely revamped it. It uses some new statistics and methods. And so we'll talk about what that will do for us. So Amanda, before I hand you the screen, anything else you'd like to highlight at this point?
Not at this point. Let's jump in and get going.
Yeah, go ahead and take it away.
All right, let me make sure I'm showing the correct screen here. All right, so you should be seeing Global Mapper right now and a little digital elevation model with a river going through it. This is the Missouri River. So the new tool that we have in Global Mapper is the ability to create relative elevation models, also called river elevation models, because that's what they're frequently used for. It's shortened to REM, but these are very different from the digital elevation models, but also very similar. They display elevation in a raster grid, just like you see in the DEM here, but instead of showing the elevation relative to sea level, it's detrended, so the elevation is displayed locally to the river, so it highlights the lower elevations and kind of ignores the higher elevations. This is useful, especially when you're looking at line features like rivers or highways or poles that you're putting through the landscape, where you want to see the change in the terrain relative to the line feature. So for example, rivers, we know that rivers flow downhill, right? It's higher up here and it's lower down here. So that information doesn't really help us. We want to see these little bitty changes as the river has meandered to the landscape, and we want to highlight those within the elevation model. And that's what creating an REM will give us. So to use this tool, first I've selected this line feature that goes through the DEM. The line feature doesn't need to have elevation, but I've grabbed this data from, I'm from the US, so this is in the US and this is the hydrological data set, but any line feature will work with the DEM, as I said. And the tool is located in the analysis drop-down menu. It's this option here to create the relative elevation grid, or an REM, from the terrain and line feature. So how does this tool work? What it does is it takes the line feature and it grabs the elevation nearest to it from the DEM, and it takes samples of those elevation features all down the line feature, And then it uses a method called IDW, or inverse distance weighting, where it creates a secondary layer that you don't really see or you don't really need to see that contains the elevations for the river. It subtracts that from the DEM, and that's how you get your REM. So these settings here kind of impact how that sampling occurs and what that created mid-layer looks like. So by default, you can probably keep the default settings. It seems to work pretty well. Of course, you have the sample spacing. I've scooched this over here so you can see the line. The reference line, how frequently you want that to be sampled. If you have more samples, of course, it'll be more highly detailed, but it'll take more time to process, and then you'll have a larger file to manage. So choosing these settings is, again, as we often say in GIS, a balance between the resolution that you're looking at and the sample size that you're studying versus how much data you're able to manage. There is an option here to generate the averaged elevation layer. This is that IDW layer I was talking about. This option lets you go ahead and generate that just so you can look at it for troubleshooting and perfecting your settings. And there's also the ability to save it to a file. Now, I would click OK, but I have a lot of data loaded here and it takes quite a bit of time to process. So like a good cooking show, I've gone ahead and processed it ahead of time. So I'm gonna hit cancel. In checking that box when I processed it, it created this averaged elevation grid, and I'll turn that on first. Again, this isn't the final project, but you can kind of see how the line feature moved through the landscape and kind of how it was IDW'd or interpolated out. But the final model looks like this. And as Jeff said, it is gorgeous. I just love these things. We can zoom in a little bit over here to the side, and we can see where the river has meandered in the past, highlighted in these lower elevations. But as you saw, the higher elevations were mostly ignored because that's not what we're interested in studying in these data sets. So if we look at this a little bit more, I'm going to look at this stream off to the side here. We can see that there's a little bit of erosion happening, and we can see here where the river has begun to get really close to itself as it meanders and it's starting to cross through, versus here an area that has already been knocked out. This is an oxbow lake where it's no longer connected to the river. If I grab the swipe tool here, I can pull this layer back so we can see the DEM underneath it. And we can see that this information, while it's visible there, it isn't nearly as clear as it is in the REM. So it's just a great way to highlight low elevations near a line feature. Now you'll notice that although this is a raster and elevation raster layer, you can export as a GeoTIFF or you could open it in a 3D viewer if you wanted. If you notice, it has its own shader over here. So these lowest elevations are highlighted yellow and everything else is a dark purple by default. Of course, that doesn't reflect the Atlas shader setting up here, which is a global shader setting that applies to all the other layers that are loaded. And that's because it is automatically assigned its own REM shader, which of course you can choose from up here. And this REM shader is the purple and the yellow. But say you don't like purple and yellow, you want to print it out on a piece of paper, and printing purple will take a lot of ink. You can create with a new tool that we have your own REM shader with different colors. To do that, you would go to the shader, add custom shader option, either from the bottom of this dropdown or from the configuration menu. They're both the same thing. And there's this new button here in version 24.1 to set elevations to match REM shader. You use this by giving Global Mapper the highest value and the lowest value, and then you click this option and it will go ahead and create the rest of the shader for you. So let's go ahead and do that. I'm going to choose my lowest elevation. From here it's -39. I'm going to round that to be -40 just so it's a nice number. I'll click add. This is the lowest elevation. It's going to be the river, so I'm going to make that a dark green here. Now click OK. And the other one we need is the highest. So that's 250. I'll click add and let's make that a nice pale yellow, just as a contrast to make it stand out a little bit. Now that I have those two set, I can click set elevations. I don't want to reverse those colors. I like them the way they are. And it's automatically interpolated that out for me. So if I click OK, I can change the setting from REM shader to this custom shader 3 that I just created and click OK. And now we have a brand new shader. The benefit of changing colors along with printing is that sometimes they can be a little bit easier to analyze or easier to put on a presentation or a poster board when there are these lighter colors like this, but the darker colors are the ones that are a bit more attractive, a bit easier to analyze depending on what type of fluvial features you're looking at. So I think Do we have any questions? How accurate is the line alignment relation to the center of the river? That depends on the accuracy of your data. If I turn this layer off and we zoom in real quick, we can see that this line feature doesn't necessarily align with the DEM, and that's because the DEM and the line feature that I've collected here were from slightly different dates, so it looks like the river has meandered differently. But because the REM layer looks at the elevations, it kind of takes that into account a little bit. If I reorganize the river here so it's on top, you can still see the new channel and the old channel. So, but again, the answer to that really depends on your data. You could even digitize a river feature if you were ambitious enough, if you had the DEM and didn't have the line feature on top of that.
Every time I look at this tool or see someone else working with it, Amanda, it always impresses me how good the outputs look and how much more information you're really able to glean from just adjusting the display of the data, essentially. I'm a big fan of this tool when we were first working on it, and I love seeing it implemented now.
Oh yeah. Another question, can this new layer be used in raster calculations? Yeah, absolutely. It's just a normal raster layer that with adjusted elevation values to it.
And we had a couple other sort of unrelated questions come in. I'll answer, Amanda, while I'm grabbing the screen back from you. Somebody asked about licensing and updates. If you're somebody who has active maintenance and support, you can always just go to our downloads page on our website and download and install the latest version. Any questions on that or any potential changes you think you may need, you can always email our support team, and we'll have both of those email addresses up when we finish up here today. So just note that the very last slide will have the pertinent contact information that you may need. Okay, let's take a look at another feature that I think is really exciting in the way that it helps us look at data. In this case, of course, we're going to be thinking about data more so in terms of a final printable map. You know, very often when we're looking at data in Global Mapper, we can do so from a lot of different perspectives. For instance, right here, I'm in 2D view, I have some imagery, we can see a line feature, and I have some terrain data below my imagery. I might choose to take a look at some of this in 3D. Zoom in quickly here, right? I might take a look in 3D. Maybe since I have terrain data loaded, I want to draw a profile of my data. And as I'm working with my data and maybe preparing my data for a final product, there could be different instances of all these different views which I want to save into my final report or into my final map. And so, oops, let me bring back Global Mapper there, sorry. And that is where inset maps come into play. So one of the new features in this latest version is the ability when creating a map layout to add inset elements. What this allows us to do is for any window that is a 2D window, maybe you have multiple 2D views open, or a profile or a 3D view, you can insert them into a map layout as a new element. So you'll see here, I went ahead and did this earlier. You'll have to excuse my lack of cartographic design skills, but I wanted to get the important information on the map. I took a profile along the length of this line and I inserted it into my map layout, as I did similarly with my 3D view from a certain perspective. So I had certain perspectives of the data that I wanted to share and show in my final map that I could go ahead and insert here. I also used one of our newer leader line features. That was part of our last version, so I can connect basically different features across my map. And what I see as a very interesting or maybe important feature of these is that they're static, right? So I was doing a whole bunch of different things in Global Mapper just now, and that didn't impact my elements because the way the elements are set up is that when I choose to insert one, and we'll just look at inserting one here. When I choose to insert one, it happens in such a way that it grabs a static instance of the existing map. So if I wanted to put in a second 2D view or a new 3D view, or maybe I have multiple profiles I need to show, I can insert them and they will be saved in my map layout here. And that's really handy for a couple of reasons. I might continue on with some analysis. And in that case, then I won't have to worry about, drawing a new profile is not going to impact my layout at this stage. And so I'll always keep whatever's on my final map as I need it. More importantly, I can always come in and refresh this. So I can go into the elements properties and choose to update the inset. That'll overwrite what's there, and then I'll have my latest or updated information in this inset as needed. And this will function just like any other features in the map layout editor. They can be saved. They'll be included in your exported maps or be part of your templates and grouped and snapped and everything else that the map layout editor offers. Now, a great new way to work with some of those different views of our data when we're making final maps. And actually, while I'm looking at this data, it reminds me of something else I wanted to show. So not a very flashy thing, but something that we had a large amount of feature requests for, where people simply wanted to be able to cut off distances of their lines. So they have a line feature, and in one or both directions, that line feature is too long. So I'm going to use this line as an example, and we'll see how it looks. So then probably not applicable here since this happens to be a river, but maybe you're, modeling a road or a linear feature that ended up being, a little too long in one or both directions. With that feature selected, we have the new ability to crop endpoints from lines. And you can choose whether you're working with the start point or the end point of the line, or both. In this case, let's just do both, since I don't quite know which direction this line was drawn. And maybe we'll go ahead, we'll take a large chunk off. Let's take off 300 meters here, just so we can see it. And we'll keep a focus on the north end of the line here. And we should see that when I crop that line has now gotten shorter. So a really easy way to quickly adjust the length of any of our line features. As with most things in Global Mapper, this is not a permanent change until I export the data or save my workspace. So a quick Control Z to undo it will bring back that line to its original length. And as you're doing that, if you needed to check, we could always go into the feature info and take a look at the change in measurement for the line feature as well. So a couple, different little things there. The insets in the map layouts being a big one, where you have the ability to now insert all those different views into your final maps.
We had a question come in. A user's
Sure.
noticed that when in this map viewer here, when they change the size of the existing insets, that the aspect ratio doesn't adjust as well.
Interesting. Not something that I have noticed before, but we'll go ahead and take a look at. And we have that as a question, so we can reach out to you if we are having trouble seeing.
I may have shorthanded this question poorly. I think what they've noticed is with the path profile here, for example, the screenshot that you have there that inherited the aspect ratio from the path profile tool as you had it open. So
Correct.
if you see the inset map, if the user sees the inset map and they want to change it, they'll need to change their path profile viewer and then refresh the inset map. So this is always going to be a static map.
Yes,
Yeah.
yes, that is correct. Yes, that's a good thing to notice and be aware of. Okay, Amanda, I think I'll hand it off to you. Do you want to talk about some of the new exciting raster tools we have?
Sure.
Okay, go
I can
ahead.
continue on my train of raster tools.
There we go.
We'll click show my screen, and you should hopefully be seeing a very familiar image. I didn't realize we were going to use the same one twice in a row.
That's funny.
But that's okay. So we're going to look at resampling methods. This is a different way, a new way to manipulate raster data. I'll first go over a simplified version that's in the standard version of Global Mapper. So it's, of course, in both standard and pro. And then we'll look at a tool that's just in the pro version. So resampling is kind of a way that you can edit a raster layer, be it an image or an elevation, to highlight features that you're looking for or to sharpen the image, depending on what you're looking for and what you would like to study within the data. So for this example here, this is Nevada. We have a little bit of shrubbery over here and some urban area and some farms, but it isn't very clearly visible. But we can change the resampling method to sharpen the image a little bit and make it more visible. And those tools in the standard version are found in the raster options. So you right click and go options, or you double click on it. And in this display tab is this resampling dropdown. And these are some new resampling methods that we've included in 24.1, where you can sharpen, you can do some edge detection to make the edges of the different features stand out a little bit more. And all of this is done by recalculating the raster values. And I'll go into what that means here in a second. So with this one, if I go ahead and choose, I want to sharpen this up a little bit. We want to see these shrubs a little bit more clearly. I can choose the sharpen option. I'll click apply, and it edits the existing feature. And we can really see, or at least I can on my machine. I hope you can see it on yours. I hope it's coming across well. If I change this back to nearest neighbor and then back to sharpen, we can really see those start to stand out a little bit. So again, it's just a different way to change how raster data, image or elevation is displayed. Now we could also do this with the Pro tool, which creates a separate elevation layer. So instead of switching back and forth between sampling options to compare the images, we can use this wipe tool. And that tool is found here, again, in the analysis dropdown. It is the apply convolution filter to layer. So a resampling is where you edit the existing layer, but a convolution filter is where you create this a different layer. So the same sort of thing, but it applies and extracts in different ways. I have a different data set that I think would be more useful for this. Let me go ahead and pull this up real quick. So we've looked at an image. Let's go ahead and look at some elevation data. This is from the Ouachita Mountains in southeastern Oklahoma. Surprise, surprise, I have more Oklahoma data. So we see here that there are a lot of geologic features that move kind of east-west. There's a filter that would let us highlight these features based on their direction. So if I go back to the apply convolution filter to layer, we can see that there is a gradient north that will highlight everything based on a kernel. But what is a kernel? How does this work, you may ask? Great question. Let me pull over the knowledge base, which has a bunch of examples and explanations here. To make it more clear, I'm on the apply convolution filter to layer tool. If I come down here a little bit, we can see the kernel that is used for each of these filters. Now, a kernel is a set of values that's applied to the raster to recalculate each pixel value. So each of these values represent a pixel, where the center pixel is the pixel that's being recalculated. And this pixel value, the new pixel value, is recalculated based on the weighted values of its neighbors. So we can see that this value here has twice the weight, this is negative twice the weight. And we can see that with the north gradient that this is directional. And if we look at the south, we can see that it's the inverse. And comparing it to the east, it's a little bit high, comparing it to the east and the west, we can see those changes in directions in the kernel. The changes of the weighting of its neighbors is how that center is recalculated. And this is, again, for directional gradients. We have sharpening and all sorts of other options that each have their own kernels to change the pixel value based on what you're looking for. But for this one, we're going to look for gradient north. So we'll go ahead and click OK to generate that brand new layer here. It'll just take a second, not too long.
Amanda, while that's processing, I'll chime in and answer a question that somebody asked. And they asked about how whether or not these outputs are just display or manipulating the data live. And the answer is, if you're doing it from the layer options menu that Amanda showed first as part of the standard version of Global Mapper, what she's showing here on screen, that will just manipulate the data display on screen, and it won't be permanent until you export the file out of Global Mapper. The latter option that Amanda just showed creates its own layer, and that layer will have inherently the new values that were calculated. Again, you still need to export it to save it, but that is its own dedicated layer of data.
And because I created this one based on an elevation layer, this is elevation data. I can take the feature info tool and click, and we can see that this does have a height value, albeit slightly recalculated. But this one was created from gradient north, and we can grab the swipe tool again to compare it to the original data. Let me scroll in a little bit, and we can see that it's highlighted some directional change. Ah, my poor computer, I have too many things running at once. But let's compare that to the west gradient that we were also looking at in the knowledge base, just as a demonstration of what some of these tools are. There is another option here that's available in Pro, is the ability to create a new filter. This lets you design your own kernel to be weighted based on what you're looking for. You can choose kernel size, you can choose to create your own extra weighted south filter, whatever you're looking for, and you can save it here and apply it to your data as you want. But let's go ahead and make a west layer here. So while these lines are weighted so we can see the lines east to west, you can imagine that the west layer will be different. It'll be inverted. So I'm going to change these layers real quick to match my swipe tool. So if I pull this north layer back, you can see that the lines in the west are very different. It's highlighting a different pattern in the data. So if we were a geologist and we were looking for these different patterns in the terrain, in the landscape, we could use these tools to look at the different structures without being distracted by any of the other conflicting features. I'm just very fascinated at how different these shapes are, even though it's based on the same elevation data. Someone says,
You really took the most visually exciting tools to talk about for this, didn't you?
I did, not intentionally. It took every other one.
Yeah, but another great one. I mean, just the difference between north and south there always gets me, or north and west, whatever gradient you set there.
Yeah, this is a cool data set for that. Someone chimed in and said this is the coolest global mapper release. It's pretty great. Right, if anyone doesn't have any questions on this, I'll go ahead and throw it back to you, Jeff.
All righty, that sounds good. So now we're gonna change gears a little bit and we'll talk a bit about automation. So over the past handful of versions of Global Mapper, we've been working more and more at adding automation tools. And in this case, I don't necessarily mean that as in, our automated LiDAR classification tools, but more automated workflow and processing tools. So we added Python scripting support a couple versions ago. We added a built-in script editor with syntax highlighting. We'll see that shortly here. With version 24, we added the ability to build your scripts. So essentially the tool would live record your actions in the UI into scripts, command, and parameters. And what we're going to look at now is the ability to record in the Python scripting language, which is admittedly still in the works and technically a beta tool, but already working really well and giving us a really handy way, especially those of us who may not be completely fluent in Python, like myself, because you haven't used it since grad school, or are just learning it for the first time, or simply just want a quick way to get your workflows into the Python language. So the script builder by default, actually, I'm going to go ahead and dock this. I like keeping this docked over here. The script builder by default always starts in the GMS or Global Mapper script, but you can very quickly toggle over to Python. I'm just choosing to do that now, so all of my steps here get recorded, but you can open this and run this for any portion of your workflows. So maybe there's only one portion of your workflow you need to record. You do not have to have this open and running the whole time, although doing so isn't really going to hurt you. There's not a ton going on here processing wise, unless you're recording huge amounts of workflows. Otherwise, it shouldn't be a problem as it's just saving that text. So let's see here. First, we're going to take a look at a point cloud that I'm going to load. Oh, just got to set my projection. I'm going to leave all my load options as default here. Of course, changing these would reflect in changes to what is recorded. Importantly here, I have a filter on, so it's just telling me that. I have a filter on, which is fine because I'm just going to make a terrain layer here quickly, but just good to be aware of. You can always adjust your filters from the filter toolbar icon. So as I'm working, you're going to notice little commands being recorded, and we'll look at those in more detail in a second. So first thing, for example, I'm going to do is go ahead and create a terrain surface. Not too concerned with my settings here since I'm doing this more for the recording than anything else, but to see what's happening. I will highlight though, we now have a new method for grid creation in Global Mapper. Some of you may recall version 24, we added a whole new geostatistics tool for variography and kriging. So that's a dedicated tool to build your variograms and create kriged outputs. What this does now here in grid creation is essentially a quick and easy way to Krieg source data to make a surface where we don't need to, tweak all of our statistics and all of our parameters and everything like that, but we just quickly need to create a Krieg surface. That is now a method available to us. As with everything else that isn't tin, it is also a pro-only method. Everything else here I'll leave as default. And then when I go ahead and process this, we'll see once that completes running, we'll get that recorded in my script builder as well. If you're curious, this actually happens to be a little lake feature, and I chose not to interpolate across the lake since we didn't get good return from water, but that's just a little tangent. So now I have my next command set here. Let's do one more thing. Let's go ahead, we'll make some contours. Also newer to Global Mapper, you'll see here that this is grabbing the point cloud too. I believe version 24 brought us the ability to make contours directly from a point cloud. So I didn't have to make the terrain surface here, but maybe call me old fashioned. I like making my contours from a surface. We'll leave our settings as default in this case. Go ahead and make a couple contours on our data. Again, recorded as part of my command. And last couple things I'll do, maybe I'll go ahead and export my contours. We'll just send them out to shapefile now. Anyway, going through this quick, just to show the process that it's being recorded, not too concerned with the output itself here. And we'll go ahead and maybe we'll export the terrain layer as well. Worth noting, as always, Global Mapper has a very large file format support. So if you're ever looking for a unique file format, you will most likely find that in Global Mapper. It's something we make sure we put an effort into so that we can support as many formats as possible. I'll just overwrite this file from earlier. Okay, so let's say at this point I'm done with my workflow. Maybe I'll even choose to stop recording. So I could leave this open, and now if I did other things, let's say go make some more contours. Right now it wouldn't be recorded if I ran and processed that again. One of the things I really like about this tool, so you get a quick preview, of the command name here, and that's more just to show you that it's happening. We'll look at details in a second. Same goes for the parameters, right? You get some parameters here, but really you're going to want to view that in the text editor itself, and we'll do that shortly. One thing I really like about this tool is the ability to live toggle between scripting languages. So you can go right from Python to Global Mapper script or back again, whether it's change of desire for what you want. Maybe you clicked the wrong one. Maybe you just want to see how one command compares in the other language. You can very quickly move back between the two, and that I think is really handy. But so what we're going to do here is go ahead and pop open the script editor just so we can go ahead and see now I have the full Python script for everything that I just did. So, the abbreviated parameters or commands here, we can see everything in detail for each process all the way down to the bounds used when creating the contours. You can see my exports of my vector and raster data, etc. One of the reasons I find this really handy, especially for those of you who work with Python quite a bit, there's always a whole variety of parameters for a specific library that you're working with. Rather than needing to learn them all for Global Mapper, you have them here ready to go. Next time you need to automate this process, grab the command and adjust what file you're working with, what units you want to work with, etc. In a really quick way to automate that process. This, of course, is a live editor, and I could type in here, if I needed to, and add more to this. I don't for this reason or for this workflow. Again, I could save it, export it, add in more files, whatever the case may be. But again, of note is the recording of Python in the script builder. I would encourage, and also as someone who's helping improve this tool, love it. If anybody who's working in Python wants to go and look at this, we're continuing to add more and more functionality to the Python script builder here. So if you see a tool that isn't recording and you want it to record, shoot us an email, let us know, so that we can make sure that that gets added into the script builder. Okay, I'm going to pass off to Amanda now to talk to us about some of the new LiDAR updates.
All righty. Let me share my screen here.
While you're switching, Amanda, any major questions come in? My questions seem to have stopped about 20 minutes ago.
You might need to scroll down. It hasn't been auto-scrolling, but we have had some compliments come in that, quote, the script building tool is awesome. I agree. And the Python support is only for the Pro license. Yes, that is correct.
Yes.
A few other questions that don't necessarily relate, but that's okay. We'll email those later. We just want to make sure we have time to cover everything.
Oh, I'm sorry. I forgot to give you the screen. Go ahead.
Oh, it's okay. I was waiting for the window to pop up.
Looking at questions.
All right. So continuing my parade of the most beautiful tools in 24.1. So in 24.1, we've expanded our LiDAR classification tools for segmentation to do pole classification. Recently, we've started reworking our LiDAR classification tools to include segmentation. And this method, as opposed to gridded, helps us better address new types of scanners, right? So the original way that LiDAR was created or was collected, of course, was from an aerial sensor on a plane. It tended to be pretty sparse. It was all top down. But more recently, we've had different types of scanners come in to collect data. Like, for example, this is terrestrial LiDAR here, or from a UAV, or from the top of a car. And segmentation can better classify all of those. And that is especially important for pole classification, because aerial LiDAR doesn't really collect poles very well. It's a very top down. It's just a top of the pole. So terrestrial is really the best way to capture that. And this new segmentation option lets us take advantage of that. It is in the non-ground classification tool up here in the segmentation tab. Now, segmentation works by, as a high-level description, it clusters points together based on like attributes. So these points that make up this pole here are all going to be of similar color, so similar intensity value as it's colored here. They're all going to be a similar pattern, kind of have a bit of a curvature, versus the edge of the building is going to be pretty flat versus the ground, which is flat and also on the ground. And that's kind of how it chunks things up and assigns classifications based on what it knows of the attributes. But because every point cloud is different, you kind of have to tell Global Mapper what to expect with your specific point cloud, and that's what these settings are for. So in the segmentation method tab, it's going to classify buildings every time it runs, and you also have the option to classify vegetation or classify poles if that's what you're looking for. These parameters up here let you set the settings, the global settings for all three of those options, building, vegetation, and poles, and these are kind of the segmentation parameters. So the neighborhood range is how far from a point it should look when assessing what that point is. If you're looking at poles, then you'll want to set that to be pretty large. I think the default is 3.5, but if I zoom into the pole here, we can see that if we look at 3 points, that isn't going to be large enough sample to register this as a curved feature. It'll look flat and it might accidentally be classified as a building. So you want to set this large enough to capture whatever type of feature you're looking at. Minimum cluster size. So any groups of points that are smaller than this are going to get thrown out. So if you're only looking to classify larger structures, such as poles and buildings, you'll want to set this a little high. So it'll ignore anything that it sees like in the vegetation that just happens to have a structure to it. And then maximum number of standard deviations. How similar do you want these clusters to be? And since I was looking at poles with this classification, I've set it pretty low because all of these points, as I said earlier, have the same intensity value. They have the same curvature pattern, so they'll fit together pretty well. Now, I've gone through in classical bake style and I've pre-run this because it does take quite a second. So let me change this to color LiDAR by classification so we can see that the poles, buildings, and ground have already been classified. If I open up this tool, there's an option here for minimum height above ground. This is to help weed out the noise, the clutter that sometimes appears above ground points, especially with aerial LiDAR or with vegetation. I've set it pretty low, 0.5 meters, but that's this little water line you're seeing at the bottom of buildings. And since a lot of this is on pavement, you could probably set that even lower to get rid of it. And then with poles, one of the benefits of using this as opposed to the other pole option is that it gives you the settings, the thresholds for minimum and maximum diameter. So this tells Global Mapper how wide you expect your poles to be and lets you kind of weed out some of the vegetation there as well. I kind of left some of the vegetation here just so I can show you a different tool for how to reclassify that, but I could limit this pole diameter a little bit more to be more specific to help weed this out as well. The benefit of using segmentation again instead of gridded to look for poles is it does a better idea, a better job of looking at the rest of the structure of a tree versus a pole, because it can get confusing. Remember that poles were once trees and they're of similar structure, but the extra vegetation kind of helps that go. This tool works whenever you do click OK by classifying buildings and poles first. So it looks for conical features and flat features and classifies those. And then if you have classify vegetation selected, it'll run through another time and look through the remaining points to pull vegetation from those points. So that's kind of how that works. Now, once you have it classified, there's a new tool that I always like to show just because it's so handy dandy, and that's an easy way to reclassify data. So we see within these this vegetation area here, again, I could have fixed it with my settings, but we see that there are some poles that have been erroneously classified. Instead of going through and manually selecting each section and saying like, oh, this isn't pole, we have a filter LiDAR data tool that lets you reclassify based on its current classification. So I've switched to a top-down view. We can see that I have individual poles here, but pretty much everything else here that's classified as pole, I do not want to be. So with the digitizer tool, I'm going to go ahead and select, whoop, I have to select it in 3D view. There we go. Let me select these points here. Careful not to select the points that I actually want. And these will show up in red. And then the change LiDAR classification tool is up here in this manual LiDAR classification toolbar. And this gives me the option, it automatically populates with all of the classifications that I already have selected. So I'm going to uncheck all except transmission tower because that's what I want to change. And I'm going to change transmission tower to unclassified because we haven't changed vegetation yet. And you can see that I have building points selected, I have ground points selected, but it's going to ignore all of those because they weren't checked here. So I'll go ahead and click OK. Lickety split is already reclassified. I'll click away to unselect and it'll refresh my 3D view here. In theory, there we go. And we can see that all of those points have changed. So it's an easy peasy way to help kind of do some manual cleanup on your data in the cases where it's needed. But once you have your poles classified, you can again come to this extract vector features tool, and based on the classified LiDAR features, it will extract this to vector features. So for a pole, it'll create a point feature at the full height of each pole. So I have these settings set. These are just default. I'll go ahead and click OK, and it's going to create those point features at the top of each pole that it's classified. Let me split. I'll turn off terrestrials just so we can see the points. They've maintained the elevation data, and it also, from this top-down 2D view here, you get a point for each pole that it has collected. And that's a little bit about the new pole classification tool.
Also worth noting how much, at least to me, how much I like the sweep select that you did in 3D view there. Not a new feature, newer, but not brand new. I think it's such a handy way to edit LiDAR in 3D. Just
for
with
sure.
click and drag on 3D points there.
Someone has a question about collecting power lines. We do have that option. It's here in a different tool, in the auto classify power line and power pole points. That's again the gridded option instead of segmentation, but it will still classify the wire points, and then you can, just as I did, use the extract vector features to create line features from these wires that you can use in a buffer analysis to select all vegetation points within a certain distance of these line features if you wanted to.
Yeah, there's a dangerous slippery slope there, isn't there, Amanda? Of all the all the cool additional things we could do from this workflow, huh?
Oh yeah, I am holding myself back from going full segmentation explanation. It is one of my favorite tools in Global Mapper.
Okay, well, I will help you restrain by grabbing the screen back, and we'll take a look at two more tools here, or maybe three more before we wrap up. I know we're getting close to the top of the hour. Okay, so the next two tools that I'm going to talk about anyway, although unrelated, both kind of focus on, I guess we'll say, improving workflows or maybe streamlining workflows within Global Mapper. But very often, for those of us who are working in a GIS day in and day out, you're doing a lot of things, a lot of different little steps, and we're looking at how do we make some of those easier. So the first thing we're going to look at is an improvement to the mobile data merge tool. This tool has been around for a couple of years now, and what it allows us to do is sync up the ways that we are sending data to and from mobile devices for users working out in the field in Global Mapper Mobile. And so what I have up here on my screen is a workspace that I sent out already to someone in the field. And it is nothing fancy but a base map of where they're going and a template layer for them to record data in. As a little aside, a template layer is, think of it like the structure of the data they're going to collect. So in this case, they're going to go out and collect points and give those points certain attributes based on what is set in the template. Now, where it gets exciting is bringing that data back in to Global Mapper. So the mobile data merge tool here, it's opened off screen, gives us three different options. First, we're going to look at the import option here because that's where the new functionality is. But we'll talk about briefly exporting and device link in a second here. So remember the data I grabbed earlier, but I can always choose what data I want to load and what I want to merge it with. So you'll see here my to file, or the data that I'm merging the field data to, in this case, is my loaded data. So this is also new for 24.1, where if I have sent data out to users in the field, I can now directly merge it back with the original data that I sent them. So I don't have to go back and forth looking at data, bringing it in, looking at data, bringing it in again to a different workspace, and then merging everything. I can also, and have chosen to only see the differences, right? So I don't need to see any duplicated data if nothing changed. There's no point for me to see that. I have the ability to expand my layers here so I can see the details of what exactly changed and what the new values are associated with them. Now the viewer here, also off screen, now shows me my source data and the data from the field. So in this case, all that changed was the points that were recorded, and I'm only seeing the differences. So we'll see if I'd wanted to see the base map, I could see that too. But right now, I have my data and the views are linked. I can zoom in, zoom out, and pan around just like I would in a 2D view. So I can also, take a look at a point. Maybe I'm concerned about this point. I can see where that point lies on the map. Any features I select in my list get highlighted, and it gives me a really handy visual way to confirm or reject the data that I'm bringing in from the field. And I can, this tool allows me to either all-encompassing, say keep everything, or I can manually select what features I want to keep on merge, but I could choose keep all, and then merging it would save it into my workspace here, and I would have all these points now. Before we move on from this tool, it's worth noting, if you're someone who uses Global Mapper Mobile and you have access to Global Mapper Desktop here and you're on the same Wi-Fi network, you can select whatever network you're working on, so anything that's available to you, and choose to connect to a mobile device on that network. Now, I don't have my phone open with Global Mapper Mobile right now, but if you did, you would see any of your phones or tablets populate from this list, and then you can get or pull files right from that device. So no more plug it in, drag it over, email, Dropbox, Drive. As long as you're on the same Wi-Fi network, you can do it all right from within Global Mapper, including exporting a specific package file for the mobile device, along with adding data that's not in Global Mapper. So if I said, oh, I forgot my roads layer, I could go grab some roads, throw them in here, and send it to the phone. Okay, so that's one of, I think, our little, workflow streamlines and improvements. Let's take a look at something, I would say a little more exciting, but a very different tool. So our Pixels to Points tool has been around for a while, and that tool is our photogrammetric point cloud tool that allows users who have flown a drone flight to import the images from that flight, build a 3D point cloud, an ortho, and or a mesh feature, any or all of the above that they may want, and then use for further processing, whatever the case may be. Well, that can be a very complex workflow. And so now we have added a wizard at the start of this page, which is optional. You can always just skip it and go right into the main tool for those of you who really like to get hands-on with their workflows. But let's go ahead and add some images in here. I'll just add a couple sample images and choose my output. So our goal here is to streamline the process when you don't need to get into tweaking this setting and that setting, and I need this output product and that output product, but a quick way to generate some data. So this is probably the most important page to be aware of, where we have the ability to choose what we want our output to be. Could be an ortho, could be a 3D point cloud, a quicker ortho, or a quick 3D model, right? So effectively, quick means process is faster to get you a quick output at the trade-off of quality. Or you'll see in this case, right, I made an ortho here that we'll look at in a second, right? Higher quality, but a little bit longer processing time. And it gives you a little bit of a feel for flight type. So maybe you don't quite know what you need for the best output. So it'll give you some ideas on image orientation and collection type to help guide you towards what you need to do. Once you've chosen your method here, clicking next will bring you to the main tool. And really here, all you would want to do is go ahead and choose to run the tool. At this point, the one caveat to that, and I actually just saw someone ask this question, is if you want to add ground control points. Currently, ground control points are still added in the main tool, simply from our initial thinking that, well, if someone's taking the time to add ground controls, they might want to be a little bit more hands-on with all of their other settings as well. So that's why you still get this pop-up. choose your ground controls if you want, and then go ahead and click run. We're not going to wait for that today because it'll take a little while. So let me go ahead and find the completed version here that I did a little earlier. And we'll take a look at the outputs. There we go. Let's see, it should be what we want. And I probably have my point cloud filtered from earlier. So always a good reminder that filtering is global in Global Mapper. And now I have my output point cloud. And so by default, as I'm sure many of you know, one of the nice things we get from photogrammetry is color with our point clouds, which we don't always get from a traditional LiDAR scanner. So in this case, when I ran this earlier, I just made the ortho. I could have chosen to make the mesh or the ortho as well. So now I have that output, no different than if I had, regularly run pixels to points. It's still three-dimensional. I can see here, when I first looked at this, I was like, huh, looks like maybe there's, quite a few holes around and blind spots around my buildings. But really then when I took a look in 3D, look how close those buildings are to each other. It's not surprising that we have a little shadow in there from our flight. But to that end, a great point that, maybe I chose to do this instead as a quick ortho when I'm out in the field. And then I see, very quickly, okay, looks like I have some gaps here. If I fly this again and get a little more data, will it allow me to quickly go ahead and get a better output? I think you'd be pretty hard pressed in a situation like this, given the small space between the buildings, but that's a conversation for another day. The important thing being that we now have a little bit of a wizard to guide us through the pixels to point setup. And for those of you who are looking forward to using this, keep an eye on it. We already have more in the works for it. So it will continue to expand a little bit. Amanda, if we don't have any questions on that, I'm going to go ahead and pass back to you here so we can take a look at our last workflow before we wrap up.
All righty. So this is continuing on the pixels to points updates. This is a few updates to an existing tool, the Cloud Compare tool. It's one of these, this little blue Venn diagram tool up here. So this existing tool in Global Mapper compares point clouds. It performs what's called a change detection between 2 point clouds to find points that have changed between them. So this is good if you're measuring change detection, like erosion. If you have 2 point clouds from the same place from different points in time, you can measure the difference between them to see how much soil has eroded. You could compare different point cloud sources, aerial versus terrestrial LiDAR, and to see how your sensor matches up to a different sensor. But it's especially good for estimating the accuracy, or as kind of a QA tool for pixels to points. This photogrammetry in general, because it's based on imagery, sometimes can have a little bit of error to it. And this can be a method for figuring out if you have erroneous patches in your data that you need to look at, or something that you can improve in a workflow. This is a good tool for that. So I have two LiDAR layers here, 2 point cloud layers here. I have a USGS layer, which has a bit of QA/QC already done to it. So we're going to use this as our truth layer that we want to compare to. And I also have a photogrammetrically generated point cloud here. This is data that was submitted from a user. This is just of a school in Maine. And this data is pretty good, but we want to look and see about how it matches up to the ground layer underneath it. So before I open the point cloud tool, I'm really mostly interested in the ground points because of how photogrammetry works. It can sometimes be hindered with vegetation and shadows, as we saw in Jeff's last data set, because it can only map what it can see. But it can see the ground pretty clearly here. So I'm going to filter LiDAR data and turn off everything but the ground. So we're only comparing those points. Again, this is pre-classified, and that's why I was able to do that. But I'm going to go ahead and open the Compare Point Clouds tool. I'm comparing against the USGS layer, and I'm finding changes in this photogrammetric point cloud layer. So those 2 new features down here are these 2 check boxes here in the bottom. The first one, when it measures the distance between the 2 point clouds, it saves that distance in in the generated point cloud that it's going to make as a generic field. It's titled generic field, and that is the attribute that we'll be able to see in Global Mapper, and we'll also be able to color by that attribute as well. And then in addition to that point cloud of difference points that we're going to see, it'll also generate a difference report. And this is kind of more of a statistical report and some histograms on the difference in distance between these 2 point clouds, so we can see it from another visual perspective. So I'll go ahead and click OK to kick that through real quick. It'll tell me how many points were not in the original point cloud, but I'm more interested in the difference in distance between these two. So I'll click OK. It's created the new layer here that only contains points from one point cloud that were within a specified distance of the other point cloud. So which points were in the photogrammetric point cloud that were pretty far away from the LiDAR? Those are the points that have been created and highlighted here. So if I turn off the other points, we can kind of see those here. I'll unselect them so we could see them a little bit. We can see if I turn on an imagery layer I've pulled underneath it, it looks like there's a lot of difference here where the cars are. So it looks like there were more cars here when the USGS took that sample rather than when the photogrammetric sample was done, and that's fine. But we can especially see that there's a little bit of an error here where the camera wasn't able to get as much information in the corner of a building as well, and that's kind of expected. So it lets us see which areas have a bit of an issue, and we can see the coloration of the distances, so how much error there was. If I look at the photogrammetric point cloud and I change the shader to generic value here, and here we can see the distance as measured in this little shader that popped up. And these directly correlate to these histograms. So we have the source to reference distances histogram, and that looks at the USGS data. So this is a little low, and that's kind of what we expect with a lot on 0, especially since the boundaries of the USGS LiDAR layer exceed the boundaries of the photogrammetric data. But we can see in the reference to source, so this is the photogrammetric layer, a nice bell curve, and that's what we would expect to see. You can see the distance down here, so this is how far away from the other point cloud it was and how many points were far away. So we can see that about the average was 0.8. Now I know this data set came with ground control points that I didn't use during processing to make this a better layer. A disclaimer, because I know the user who sent this data is definitely here in the chat. So I didn't create it to its best effect, but it's a really good example at using this difference comparison to measure the difference between 2 of these point clouds. Are there any questions? I know we're a little bit late here, but this is always a great tool to show. It's another useful QA LiDAR tool to add to our existing pretty expansive set.
Yeah, absolutely. Thank you for sticking late with us. If you're still here, Amanda and I were talking, oh, are we going to be able to fill an hour today? I guess we know the answer to that. Well, Amanda, thank you for being here and helping me out today. It's a pleasure, as always.
Well, thanks for having me.
Yeah. Thank you to all of you who have attended. I mentioned earlier, for those of you who had questions about your orders or licensing, choose the top email here. It's a simple one, orders@bluemarblegeo.com, and they'll be able to help you out. Any technical questions? I know I answered a couple questions in private technical ones, that is. Send an email to GeoHelp. Our support team is great. It can get to me or anybody else if it needs to. So go ahead and use those resources as well. Again, this is recorded. It will probably be a week or so. Don't hold me to that because I'm not responsible for that, but it will get on our YouTube page sooner than later. Excuse me. Thank you again and have a great day, everybody.